trained for rotorcraft operations and aerodynamics. Okay, so this is very important. This needs to be take some time, and I need to give you as much as information, whatever. So we'll talk more about rotorcraft operations and aerodynamics going forward. Okay, so let's see. Historically, the unmanned air vehicle, even before actually the aircraft were tested or flown in 1849, Austrians used balloons as an unmanned aerial vehicle for attacking the Italian city of Venice. Okay, so they used the balloons, and these balloons were flying. So these were unmanned. I mean, there was no control on it. It just, because of the hydrogen or helium gas, the balloon used to go up in the air. The air in the atmosphere will take that balloon as it intend to go. There is no control of it. It was attached with the explosives on the basket. Okay, and at certain extent, automatically those explosives were detonated. Okay, so it was just released on the city randomly. There is no control, but this was the first attempt to try to do something unmanned aerial vehicle kind of thing. Okay, so this is was known as. Same was used during World War II also by Japan. Okay, so Japan used to flow this type of, but little bit more better mechanism, better control, but still they were not successful because the drones which the balloons which were flown that point in time over the Pacific Ocean, they never reached California or Las Vegas or the western coast of America. Okay, most of them were lost into the sea. I think only one balloon out of those whatever balloons they flown was reached the land. Okay, but unfortunately or fortunately, I would say nobody was injured or nobody was attacked by these balloons. Okay. Okay. So that's the beginning of unmanned aerial vehicle. That's what is the as per the history what we see. Now let's see who actually is called as father of drones. And these are a couple of slides which are just with respect to the information you should know who actually invented the drones or who actually invented the first successful commercial drone. Okay. The father of drones, Dr. Abraham Karim, he was born in Baghdad, so he was actually Iraqi. Later moved to the Israel in 1951. He done his aeronautical engineering from Techon, Israel Institute of Technology. Built his first drone during the Yom Kippur War for Israeli Air Force. Okay, so that is the time when he built the first drone for Israel. In 1970, he immigrated to United States. There he found a leading system incorporation, started manufacturing his first enterprise drone known as Albatross. Okay. Later on, this Albatross drone was acquired by the US Army and it has been renamed as Predator drones. Okay, so that Albatross, whatever the drone was found or manufactured by Dr. Abraham Karim's company, Leading Systems, is been now acquired by the US Defense and been renamed as Predator drones. Okay, so because of this, inventor of the modern day combat drone, Predator, which got him the title of father of drones. Okay, so that is the world's extensively used drone in military or defense combat missions and other things. So this was extensively used in Afghanistan during Afghanistan war time. Okay. So what are the basics drone overview? Types of multi-rotor drones, quadcopter, anatomy, terminology, inner electronics, and drone and application. So this is, we'll talk in detail about the rotorcraft and the components of it. Okay. So what is actually a drone? Drone is nothing but aerial, ground or underwater vehicle without a human pilot on board. So this is very important statement. Okay. When we say drone or unmanned aerial vehicle means what? Without a human pilot on board. Okay. So it could be a quadcopter, it could be a ground vehicle, or it could be underwater submarine also. Okay. Without human inside. It is known as unmanned air vehicle. Okay. UAV. Or remotely piloted vehicle, RPV. So when we have a UAV, RPV, so these are only we are talking about the device, okay, or the mobility device. Whereas a complete system will have a system word, okay. So UAS, unmanned aircraft system or remotely piloted aircraft system, that is RPAS. So when we say RPAS means a complete in totality. It's not only about drone. The drone along with the remote control, GCS, even you as a pilot becomes the part of RPAS. Okay, even your co-pilot becomes the part of RPAS. Even you have some devices to maintain, measure, monitor, whatever the part of the system is called as RPAS. Okay, so that's how you define either RPV or RPAS. Okay, so that is what I think. RPAS is nothing but RPA plus GCS or the ground control station. So when these two combine, that is what we call as RPAS. So when we say ground station means what? The pilot will also come be there because he has to be there, monitor, maintain, he has to give the command, execute, all that things, or you need to pause or maybe take manual control, all that things will be there. So that will be RPAS. Okay. So how does drone works? It may be remotely controlled by human operator. So you will have a person holding a remote and he will be controlling it. Okay, so that is what we call as first subcategory. That is RPAS, remotely piloted aircraft system. Okay, or fly autonomously with the help of onboard computer. So your ground control station, you will define the mission plan and you will give execute. So once you say execute or upload and execute, so once you give upload, that whole mission will be uploaded into the drone flight controller, and then flight controller will get a command from the ground controller to execute. So once it get execution, it will execute the mission plan based on the onboard computers on the drone. Okay, so that's how the drone flies. So multi-rotor drones can be of different types. It can be more than 2 rotors. So tri-rotors, quadcopter, even 2 rotors drones are available. So tricopters, 2 rotors are there, quadcopter. But 2 rotors, 3 rotors, these are little bit unstable. They need lot of computational power required to maintain them stable. Okay. But whereas when we have a drone of a quadcopter, okay, or a hexacopter or octocopter, okay, anything above 4 and more, they are always stable in even numbers. Okay, you can't have 5 rotors or 7 rotors or 9 rotors kind of. So we'll always have an even number 4, 6, 8. Okay, so quadcopter is very extensively used rotorcraft. Okay, because of its stabilization. When you have a more power required, more weight to be picked up, then you may require hexacopter or octocopter. Okay, whereas for normal surveillance or any other photography, cinematography type of drones, you will use always a quadcopter drones. Quadcopters are most popular and widely used variants. Okay, so multi-rotor drones. The pros is vertical takeoff and landing, hovering capability, operations from a confined space. Okay, your aeroplane cannot go in a confined space. It needs a big space to move or maneuver. Whereas your drone can hover. That's the first important capability or pros of the drone. Second is that it can vertically take off and landing. Okay, that is what the second most. These two important actually has gained a lot of importance for the drone flying. Okay, the vertical takeoff and landing and the hovering capability. And the third most important is operation from the confined space, a small space. It can go inside the wind turbine also. It can go inside the or below the railway tracks also, below the railway engine also, or within the spaceship, not spaceship, in the ships also. Okay, so there are wide applications for drones, even in the chimneys. Okay, in the chimneys also it can go and takes the structural analysis of the chimneys, or even in the industrial surveillance where it has to go through a very difficult mission. Like I have seen one of the students who had joined for this course has been using this drone for monitoring the oil rigs, below the oil rigs. Okay, where there is very difficult, sending a human was very difficult to monitor or check the below the oil rigs of locations. So there they are extensively using drones. Okay, so operations from a confined space or very difficult situations or locations, there you can use multi-rotor drones. But what are the limitations of these multi-rotor drones? Limited endurance compared to fixed wing. Less chance of recovery in case of motor failure. I told you, right? In even one single motor failure, your rotorcraft will fall down. So chance of recovery is very less. Again, it has limited speed with compared to the fixed wing. Okay, and it cannot perform high altitude long endurance. High altitude, 20,000 feet. Why doesn't a multi-rotor drone cannot go or perform high altitude long endurance? Any idea?
The air becomes thinner, right? You cannot go higher.
Correct. So air, as you climb up, your air becomes thinner. So it is, I told you right, during the Newton's third law of motion, the pushing the drone back, it becomes very difficult. It has, the rotor has to move very fast, okay, and it has to push. It has to be lightweight. Until, see, that's why you see DJI drones can go very up in the air in the high very fast, because they are very small. They are very lightweight. Because, and the amount of propeller motion what it requires, it can take. It can go very fast in that, but it cannot also climb very high up in the air beyond, let's say 2000 meters or 3000, 4000 meters. Even DJI will not fly up air in the high. Okay, so there you will have a difficulty. It will start consuming more battery. Okay, so best option is high altitude long endurance is basically done with the fixed wing, not with the multi rotors. That is why, because of the thin air. Just a minute. I think Mr. Kedar Patil has disconnected from the.
Hello?
Kedar, you joined?
Yes, I was disconnected due to the network issue. I rejoined 5 minutes ago.
Okay.
Yes.
So let me know if you have missed out anything. Okay, I can.
I missed the previous slide
Before this.
Yes.
Okay, so basically this talks about how drone works, remotely piloted control, like you have a remote or a ground control station to control. If you are manually flying it, you will give a controls through a remote control. If you are flying using a mission flying or autonomous software, you will give a control from GCS, and the plan will be uploaded to the drone, and you will execute, and the drone will function as per the mission. Okay, you can have drones with 2 or more rotors. Okay, so 2 or 3 are basically not so stable, or they are not being extensively used, because there needs to be a lot of computational is required for making them stable. Okay, so that will be actually eating up a lot of your battery power. Whereas quadcopter is the stable drone. Okay, small drones are already made of quadcopters. If you have a more weight to pick up, then you might go for hexacopter or octocopters. Okay, whereas quadcopters are most popular and widely used variants. Okay, we saw the pros and cons of the drones, that is vertical takeoff and landing, hovering capability, operations from a confined space. These are the promising factors about the multi-rotor drones, or the pros of the drones. Whereas limitation factors are like endurance compared to the fixed wing, chance of recovery in case of motor failure. Like in fixed wing, if your rotor stop working, you can still glide the aeroplane and land it safely. But not in a case of multi-rotor or a quadcopter. Again, it has a limited speed because it is using in a different principle. It is not using the Bernoulli principle for flying. Okay, the propellers are designed with the Bernoulli principles, but it is using Newton's third law of motion for its vertical motions and flying motions. Cannot perform high altitude long distance because of the same limitations. Okay, about the Newton's third law of motion. Okay, so air becomes thinner. It will become very difficult for drone to go high up in the air. Okay, so what are the components of the drones? We have seen in other example also that you have 4 arms, which are we called as the airframe. Then you have 4 motors at the 4 arms with the propeller attached to it. Below the arms, you will see something called ESC, electronic speed controller. Nothing but it's a regulator. Okay, so when your motors are running, the speed which you need to control. So electronically, you need to control the motion. You can't change there with the button, right? Like how we change the motor span speed in our house, right? When the rotorcraft is in motion, okay, it is in flying condition. There, how will control the speed of the propeller? So that's why electronic speed controllers are used, ESCs. Okay, so you will give a signal. The flight controller will give signal to the ESC, and then ESC will give the control to the motors, which will give motion to the propellers. Okay, then it will have the camera, the first person view, the video camera, FPV camera. Then you will have a flight controller, you will have a receiver, you will have an additional camera as your payload. Okay, the camera with the gimbal, so that your drone is able to capture the images or the videos as you require to fly. It will have a landing gear or landing struts, what we call, so that it can safely land the drone on the ground. Okay, when it has to land. So these are the components of the drones. So let's see individually what are the components. The first component is the propeller, converts the rotational motion to the thrust. There are types of pushers or puller propellers. Pushers are clockwise, pullers are counterclockwise. Okay, So there are actually two types of propellers. Have you noticed any time there are two types of propellers? Have you any time got a chance to see the propellers and look into it and how this propeller function? Any idea? Have you seen any time the propellers closely? How they are? There are two types, clockwise and counterclockwise. I mean, there are two different types of propellers, I would say. Okay. No worries. During the practical sessions, we'll see this practically also, and I will explain you how they are two different types, clockwise and counterclockwise. Okay. Propeller dynamics can be modeled using Bernoulli principle. So basically, propellers are designed using Bernoulli principle. So it will have a leading edge and it will have a trailing edge. Okay. And as it motions, as it moves the rotational motion to convert the thrust, okay, convert the rotational motion to the thrust, that is using your Newton's third law. Okay, so that is how. So if you see this, there are two types of propellers. This is counterclockwise propeller. This is clockwise propeller. Okay, this is counterclockwise. That means this propeller will rotate this way, this direction. Okay, whereas this propeller will rotate in this direction. Okay, this way, clockwise. Similarly, your motors are also clockwise and counterclockwise also. So basically, motor are used to rotate the propellers. Brushless DC motors highly efficient and long lasting. Okay, earlier we used to use DC motors, but DC motor has its own limitations, and because of the friction, they used to get worn out very fastly. But by invention of the brushless DC motor, the entire game change, especially because of the brushless DC motor, the drones also has gained the wide popularity, or the popularity what has gained in the drone segment is also because of the brushless DC motors. Okay, so they are highly efficient and long lasting. Key parameters to focus is motor speed, thrust value, compatible ESC and compatible battery. So when you are designing a drone, you have to first take account of the motor. So motor will give a thrust value. Thrust value is nothing but, in a simple example, I would say this is a motor which can take a weight of 10 kg. Okay, so one motor will able to pick the weight of 10 kg. So you have 4 motors on quadcopter. So 4 into 10. So what will be the capacity? Hello? What will be the capacity of your drone? One motor is having a capacity of 10 kg. You connect 4 motors in quadcopter. So what will be the capacity of your drone to raise the 40? Okay, theoretically it is 40, but practically we never use 40. We'll always divide by 2. It will be 20 kg. Okay, so the capacity of the drone at an ideal scenario in a normal flying condition, because when you are giving a throttle, that time you may require more power. Okay, so you cannot have a payload at 100% motor proportion. You will always define it as 50%. So that's why if the capacity is 40 kg, we'll divide it by 2. That will be the capacity of the drone with the payload. Okay, that is how you will design. So when I'm saying my drone is having 24 kg weight or 25 kg weight, that means it is designed for 50 kg. Okay, the motors what it is having is designed for weighing the 50 kg weight, but we'll always make it half. So we'll be saying always that my drone is having capacity of 25 or 24 or 25 kg. Okay, understood? For example, I'll give one more example. I have a motor with a thrust ratio of 6 kg. I connect 4 rotors or 4 motors to the quadcopter. What will be the capacity of my drone?
Sir, can you repeat the question?
My motor is having a capacity of 6 kg. I connect 4 motors to my quadcopter. So what will be the capacity of my drone?
12 kg.
Theoretically and practically, both you can tell.
Theoretically
24 kg.
Practically, yes.
And practically
24 kg, but 50% load capacity what we consider, that is divided by 2, so it will be 12 kg. Clear? Understood now? How the weight is being considered, or how weight is being considered during the designing of the drone. So when I am designing a drone, I need to consider what is the weight, normal weight it has to pick up. Then I will design based on that. So if for example, I want to design a surveillance drone of 5 kg. When I say 5 kg, I have to not divide, sorry, I have to multiply by 2. So I have to design a drone for 100% efficiency by 10 kg or more. Okay, then I can consider for 5 kg operations. Okay,
So it can be 6 kg of thrust and 4 kg of motor.
no, I didn't get you.
Like if it's a 24 kg,
Mm-hmm.
so each motor, like each motor can produce 6 kg of thrust and 4 kg of motor.
No. 24 kg of weight in operations. Okay, but its theoretical value will be 50 kg. That means each motor has to produce at maximum efficiency 12 kg of thrust.
12
At
kg.
100% efficiency, it has to carry 12 kg, 12 or more, 12.5 I would say.
12.5.
12.5 into 4 will be 50.
Hmm.
Divided by 2 will be 25.
Okay.
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 Now, to control these motors, we need electronic speed controller, or we call it ESC. Used to vary the motor speed for precision, can control the direction of the rotation of the motor, CW or CCW. So there are 3 wires. You can see here there are 3 wires. If the motor is rotating in one direction, you just change the two wires, reverse the wires, your direction of the motor will also change. But in enterprise drone, you don't do like that, because in enterprise drone also your motors are also designed for clockwise and counterclockwise. So there you have to use the right amount of motor, right type of motor, right type of propeller only. Okay, you don't interchange करके वो हो जाएगा, but that is not a right way of doing. If the motor is designed for clockwise motion, you have to use that motor for clockwise motion only. Okay, because in a bigger motors, the amount of if you see the internal structure of the motor, there are magnets, they have been aligned for that particular motion. If it is designed for a clockwise, you have to use that motor for clockwise. It will perform anti-clockwise motion by changing the wires, but it will not give you that 100% efficiency what it has been designed for. Okay, so you have to, in enterprise drones, the motors are also oriented for the directions. So there will be marking on the motors. So you have to see that if there is a marking on those motors, you clockwise है तो clockwise ही करना है वहाँ पे. Anti-clockwise है और counter-clockwise है तो you have to use counter-clockwise. But cheaper drone motors, which cost hardly 400 rupees or 300 rupees, smaller, which we make drones for fun. Okay, for making model drones or learning for purposes. Those are very cheaper motors. Those motors you can use both directions, clockwise and counterclockwise, by just changing because even those motors are not given orientation, or they do not have marking, so they are all same. So you can, based on your requirement, you can use those motors for your orientations. Okay, so this ESCs also can act as a dynamic brakes. They are battery eliminating circuit powering the flight controllers and receivers. So you can see there are some small controllers are there which can give the controls, okay, or power to the flight controllers or the receivers also. Okay, so ESCs can be used. So this is basically like a speed controller. Okay, it controls the power by giving the signals to the motors. Okay, now how does this ESC gets the signals? So signals are being got from flight controllers or autopilot, what we call. They are the brain of unmanned aircraft system. Okay, helps to flight stabilization, navigation, fail-safe redundancy. All that things are being configured into the flight controller. The famous flight controller is by autopilot, which is called as Pixhawk. Okay, Pixhawk is there, and then you have other things also like DJI M3, NASA M-Lite, NASA MV283, or even third-party customized flight controllers are also, or even nowadays some of the OEMs in India also are manufacturing their own flight controllers, but they are still in a small in size and small purposes. Like FPV drones, there are people who are manufacturing the flight controllers, but larger or bigger drones, the people are still relying on the autopilot Pixhawk. Okay, this is widely used flight controller. Okay, so there is a variants of Pixhawk. Okay, and if you see in our agripod drones, we are using Pixhawk orange cube or orange white. Okay, or white cube. These are the names or terminology used for those flight controllers from Pixhawk or autopilot. Okay, so they come in a range of like somewhere around 30,000, 40,000, 50,000. Even sometimes some flight controllers are designed for 80,000 rupees also, or lakh rupees also. Okay. So they have a various controls, and from where you can control the ACs and control the motion. So basically it helps in flight stabilization, navigation, and fail-safe redundancy. Okay, so using the Pixoc flight controller, you can completely control your drone in flight. Okay, then airframe is nothing but what we call as a metal frame or a carbon frame, or even people had made with the plastic, aluminium, different components have been used to make the airframes. Okay, UA airframe consists of housing, enclosing, electronics, motor booms, arms, and platform. Different configurations of quadcopter. It could be S shape, X shape, plus or minus shape, or H shape hybrid also. Okay, so different, you can see here shapes are there. Different types of drones frames are being used worldwide. Okay, then powering the components. Okay, you require about battery pack. Okay, so power plant of UAE. So when we are talking about quadcopter, it is more or less we'll talk about the battery pack. Okay, whereas in fixed wing we talk about the battery pack as well as the internal combustion engines. But in a quadcopter, it will be maximum 99%. I would say it will be always battery pack. Okay, so it will be rechargeable LiPo or rechargeable lithium ion, which are widely used globally. It is a high energy density compared to the conventional batteries. Like normally our cells, like we use in AAA or AA cells in our torches and all things. Compared to that, these lithium ion batteries are very high energy densities. Okay, their discharge rate with respect to the capacity and voltage is very high. For example, like you can see, there is a picture of 5000 mAh battery which can power your drone for 10 minutes of flight. If we use 10,000 mAh of battery, it can power your drone for 16 to 18 minutes. So now you would say, ask me, like, if it 5000 is giving me 10 minutes, why the double capacity is giving less? Because there your weight of your battery is increasing, which is actually eating your endurance capacity of your battery. Okay, that's why you are not getting exactly by doubling the battery power from 5000 to 10,000, you are not getting the double flight time. You will always compromise on the flight time with respect to the weight of the battery, because that weight of the battery is increasing, right? 5000 mAh may be weighing me 500 grams. Okay, 10,000 mAh may weigh me 10,000 kg. Okay, so double over my weight. So automatically my drone will become heavier. So it will compromise on the weight to ratio over there. Okay. So then other components are camera gimbal used to mount the payload, help in stabilization, pan train control. So before gimbals being used on the drones, people used to directly attach the camera to the drone. But then later on they understood that basically attaching a camera directly to the drone, they're having a difficulty in managing or taking the shots. Okay, or they do not have a freedom, or they are utilizing too much of power of a battery for changing the angle of the, because then you have to change the angle of the drone when you are taking the shots. So to reduce that dependency on the battery and the drone and making a stable flight during the, because again it will be vibrating, that vibration will go into your shots. You may not get a very good photographs or not good very videos also. So that all that blurry photos and all things, people understood that we have to have some stable mechanism or stabilization is required. So gimbal was introduced for that purpose. Okay, so gimbal actually controls and gives you more movements into the drone payload. Okay, like camera, thermal payloads, or lidar in that sense. So you get a pan and tilt controls using the gimbal. Then you have a landing truss. We talked about it. The landing truss is nothing but it's a important thing when it comes for a landing purposes. It safeguards the entire drone and the components. So there are different landing gears available. There are fixed landing gears. There are hydraulics are available. There are spring loaded landing gears are also available. Folding gears are also available, where the landing gear goes up in the air when in the motion, like in the case of DJI Inspire. So you can take a complete 360-degree motion of your camera, so your landing gear doesn't comes into the picture. Then we talk about the radio transmitters and receivers. So radio control transmits the inputs given by the, or RC, what we call, by the pilot to the receiver on 2.4 gigahertz, right? We saw during the radio spectrum that 2.4 gigahertz is used. Communication link preferred frequency in device is 2.4 because of the maximum efficiency. So normally you will see the remote control and the drone will communicate on this band 2.4 gigahertz because this is at which you have a maximum efficiency of transmission of the signal. Okay, you can use other frequencies also, but then you will not have that efficiency. Okay, this is what is been tested worldwide, and people understood that 2.4 gigahertz gives you a maximum efficiency when you are transmitting or you are communicating between the remote controller and the drone. Whereas the video transmission is preferred on the frequency of 5.8 gigahertz as it provides less noise or less noise free or best quality of video signal. So at that frequency, when I am transmitting my video signal, I get a better video quality and noise free kind of thing, or less noise, I would say. Okay, again, not only the remote control, even your ground control. Okay, the GCS also uses the same band of frequencies. Okay, but these are fixed devices. So air end is connected to UAE, ground end is connected to the GCS controller, provides crucial telemetry data. So even like this is a normal basic remote control, but whatever the remote control what we are using is combination of these two. Okay, radio transmitter as well as telemetry. So both options are available on our remote. Our remote is like this remote control will cost you somewhere around 6,000 to 10,000 rupees. Whereas our remote control what we are using, it costs us more than 1 lakh rupees. Okay, it is somewhere 1,20,000 rupees. So that is basically a full-fledged remote. It acts like a radio transmitter receiver as well as a telemetry device. So there I can see the data of altitude, distance, speed and wind speed and all those things. Okay, so dynamic updation of flight plan and all that things also can be done through the our remote control also. Okay, then we have something called front indicators. There are strobe lights. Okay, so these are required. So these are not mandatory, but government will make mandatory when under the BVS conditions. Okay, so these two components will become mandatory. As of now, we can see strobe lights are there on the drones, or people use colored arms to understand the front side and the back side of the drone. When drone is flying, I mean, those people who have flown the drone, they might be knowing that, you know, when the drone is flying and they're away from you, you cannot make out the heading of the drone, the front side or the back side, unless you do some pitch forward, pitch back, or, you know, yaw motions. Then only you will come to know about the heading of the drone. But whereas it is become difficult when the drone is flying, when it is very away from you, it becomes very, very difficult to understand the heading of the drones. Okay, so that's why you need LEDs or strobe lights or colored arms, or maybe a reflective material you can put it on the drone to see the heading of the drone. Okay, this is very important, especially heading is important when we are flying in agriculture fields. Okay, we need to lock the heading when we are flying the drone in agriculture fields. Okay, ADSB we talk about, this is not yet been implemented in any of the drones or on the type certified drones, because this is a separate module is required to be connected to the flight controller, which will actually broadcast. Okay, it uses satellite navigation and periodically broadcast it about its presence. Okay, so it will tell about air traffic, about the weather and flight information to the person who is flying, as well as to the ATC also. So you will basically drone will be monitored. So this will be an important component in the drone when you are doing BVLOS and UTM. Okay, so that time ADSB component will become a mandatory feature or mandatory component to be installed on all the drones. Okay, so if you are designing a drone, you need to consider even this module to be incorporated in future stage. Okay, so microcontroller, the microcontroller is the brain of the flight controller. So in the flight controller, it's a big device. Flight controller is a big module. In that there will be a microcontroller and some additional sensors and all those things will be there. So microcontroller is the brain of the flight controller, collects the measurement from all the sensors, tells the motor what to do based on the both sensors and the user inputs. Okay, often connected to the ground station through radio and connect to the pilot through the control link or through the RC. Okay, so this basically microcontroller will receive the signal from the sensors as well as from the users also. Then there is a device called altitude and heading reference system. Basically this tells the drone about its motion, its movement. Okay, it tells us where the aircraft is moving. So it will tell about its motions, pitch, roll, yaw. All that information will be fed using this controller or the sensor to the microcontroller, and then that microcontroller will be transmitting those information to the RC or the ground control station. Okay, so to know what motions is taking, thus altitude and heading reference system will be measuring this information. How much yaw, how much roll, how much pitch, all that information and the actions will be done using altitude and heading reference system. Okay, then you have something called IMU. Okay, IMU is nothing but inertial measurement unit, is an electronic device that measures and reports a body specific force, angular rate and magnetic field surrounding the body. Okay, so it incorporates accelerometers, gyroscope, compass and magnetometers. Okay, so these are all components inside the IMU. Okay, necessary for autonomous flights, allows GPS receiver to work when GPS signals are unavailable. So in case of GPS failure, okay, in case of GPS failure, you can safely land or maneuver your drone using IMU. Okay, so whereas GPS module is responsible for provision of longitude and latitude and elevation point. So GPS will actually measure the latitude, longitude and the altitude, okay, elevation point. It helps navigate in viewless conditions and capture details of specific location of land. So when you are drone, you are flying and you initiate a RTL command or RTH command. So based on GPS positions, it is able to navigate back, okay, and it is able to land your drone safely. GPS module helps in enabling the return to home or return to launch capability in case of communication or battery failsafe. Okay, so basically GPS will help you to do configure this failsafe mechanism in the drones. Power modules, like normally you will connect a battery to the power module. Okay, so there is a wire which connects one end to the battery and other end connect to ESC or to PDB. Okay, PDB is nothing but power distribution board. Okay, you can have a power distribution board where you will connect this battery to here, okay, this location, okay, somewhere, and then you will have 4 locations which will be connected to the ESC. So in quadcopter you will have a 4 connections. In hexacopter we will have 6 connections. Okay, so different power distribution boards are available depending upon your drone. If you are designing a drone for quadcopter, you will have a 4 connectors. If you are designing for hexacopter, you will have a 6 connectors on it. Okay, so distributes the input from multiple ESCs, can power different accessories also or LED lights also. So on the power distribution boards, you have a different points to connect the connectors on it. Okay, so you can connect ESCs, you can connect HD cameras or LED lights or motor pump for agriculture drones. All that things are available on the power distribution board. Okay, so with that we complete the topic on components of the quadcopter or of the drones or rotorcraft drones. Okay, now let's see the applications of drones in various sectors. So application of drones, quadcopters can be used in agriculture, quadcopter can use in traffic management, forest and wildlife, homeland security, urban development, disaster management, healthcare, mining. Okay, so these are some of the applications. We talked at the start of the session also today morning about this. So what are the different business ideas? Aerial photography and videography, commercial inspection services, survey and mapping services, logistics. This is another segment which will take up a boom in the drone industry. Okay, the logistic part. Currently, number 1 is the survey, mapping and commercial inspection service. This is the number 1 application in current, followed by agriculture. Agriculture is number 2, and third is your aerial photography, okay, or videography. These are the 3 commercial segments or ideas or business where people are making. Next is going to be supply chain and logistics. Okay, this is going to be very, very huge game changer in the drone industry, or drone industry will stormed once the logistic part has been commercialized. Okay, then you have residential home inspection, drone part repairs, drone aerobatic. Again, this is also taking a lot of things, aerial advertisement. These are all which are some of the additional features within. Then we have talked about, like if you see here, we talked about healthcare, urban development, disaster management, mining, homeland security, traffic management, forest wildlife, all these, even agriculture. These are all ideas which have been used extensively. Okay, then you have something called data analysis. You do crop monitoring, you do surveillance, you do inspection. All that requires data analytics. So there are firms which have been set up. People takes the data from the drone and they do analysis and provides inputs and reports to the people. Okay, engineering consultancy like drone identification, procurement, operation. There are a lot of people who wanted to build their own drones, build drones for manufacturing. So engineering consultancies are also been set up. People have offered their like as I am offering my consultancy services to couple of organizations who are interested in building. So I'm involved into building two types of drone. One is the hybrid drone. I will talk more about tomorrow about that. And there is another quadcopter drone for surveillance. Okay, so there are two companies. One is Mumbai-based company. One is Rajasthan-based company. Okay, these are two companies which are involved with me on designing the drones. So one is designing the fixed wing drone, and other is designing the quadcopter drone. Then there are SaaS-based from, like I talked about, the flight planning controller, diversified data processing, analytics, and app development. This is basically UTM. Okay, so there are companies which are actually trying to build UTM solutions also. And then also, like initially after drone rules 2021, even insurance company has taken up UA insurance. So like now you will see there are almost how much 30,000 drones which have been registered. Okay, so we are seeing that in last 1 year the number of drones got registered on the platform has doubled. So before start of 2024 or mid of 2024, we were only having 15,000 to 16,000 drones registered on your platform. In last 1 year, it has doubled. Okay, so right now we are talking about almost 30,000 plus drones got registered. So you see 30,000 drones need UA insurance. Okay, so huge requirement. And then we are talking about this drone number going near to about doubling every year. So we are talking about 30,000, maybe in next 1 year, this 30,000 drones will become 60,000 drones. So think how much pilots would require. Whereas currently we see we are hardly, I think 15,000, roughly 15,000 pilots are available, trained pilots available. Okay, so you see the difference in between number of drones registered and number of pilots available, so registered pilot or certified pilots available. So huge potential is required for training the pilots also. Okay, so similarly insurance, you can see when we double from 30,000 to 60,000, almost double number of insurance will be required for people to take up. Okay, so with that we complete the rotorcraft operations and aerodynamics from today's topic. Okay, only left out is hybrid, but I will not take because it's already 6:18. We have already overshooted the time. If you have any questions, do let me know, or we are good to wind up today's session. I just want a minute of yours with the camera on. I think Kedar is asking anybody is interested in sharing the room in double or triple occupancy. So if you are sharing the room, you will able to save money over there in case anybody is interested. Okay, so you are a part of the group and you have the number of each other. You can communicate to each other accordingly. I mean, it's all individual choice whether you want to go for sharing the rooms or you can go for individual occupancy as per your requirement. Okay, so just on your cameras, everybody. I need a attendance sheet to be put up. So okay, prayers. I cannot see you.